The scene graph consists of a window stage, scene and its nodes in JavaFX. Here you can see the scene graph consists of a window stage, scene and its nodes. A scene describes everything that is inside a window in a JavaFX application, where the window provides a look and feel that's specific to the OS that's driving the application. The scene is completely yours to style and change. The window that most people will use is a stage, which extends the window class. Each of these concepts, stage, scene graphs and nodes, surround the scene object, and together they discharge the responsibility of rendering your application to the screen. Stage. The stage represents the window of any view in the JavaFX model. In fact, it extends the window. Scene graph. The scene graph in JavaFX represent the contents of a scene that focuses on the hierarchical relationship between nodes. Prism rendering scene graph. Alongside the scene graph, we get to see and modify. JavaFX maintains a sister scene graph and uses this to determine almost other things. How much of the scene has changed and which areas of the scene need updating. The textures required to render the scene and the rendering of the scene. Part of the reason that the JavaFX scene can be so efficient is that it caches and unchanged elements of a scene, so they don't need to be recomputed unnecessarily. Nodes are the foot soldiers of a user interface. From charts to images, layouts to shapes, they all extend the node class in some way. The node is the basic interface component that has bounds, layout position, event handling, mouse, keyboard, etc., opacity and transforms. All other UI elements layer functionality on top of the node class. Scene is responsible for four things: holding a reference to the parents that hold the scene nodes, that is most often a layout of some type, but can be a group. Optionally controlling the size of the window that can be delegated to the root node but doesn't have to be. Setting default higher level rendering properties useful for 3D scenes and the camera also for 3D. Triggering event handling behind the scenes. For each of these things impacts how the scene works and how it needs to be defined. For instance, because the scene will hold your scene graph, it must to be defined with the root node. Anti-aliasing and depth testing corresponds to higher level rendering properties which can be set as default for this the scene. Here you can see nodes must belongs to a group or layout parents. Nodes are connected to scene. Nodes interacts with scene. Scene holds all nodes in a parent and directs events. Scene interacts with stage. Stage extends window, handles UI centric styling and behavior. Now this is the end of my presentation. Thank you very much for watching it.